Hello and welcome back to my channel. Today we're going to be speaking about linear regression model. It's a type of supervised learning, and if the input changes at a given rate, then the same rate the output also keeps changing. This is called linear regression. The input and the output have a linear relationship. That's the meaning. So what does that mean? We can understand using a simple to understand example. Say if a student is there and he has to perform well on an exam, he has to put in more hours. So let's think like if a student is putting in more hours, say 10 hours a day, then he is achieving more results compared to a student who's just putting in 2 to 3 hours a day. So the exam scores are linearly proportionate to the number of hours of study put by a student. So when you look at that, as the number of hours increases, the score also gets better, and this is represented through a graph and it will be a straight line. That's why it's called linear regression model. Here we also say that the input is the independent variable because it's the hours put in by a student. So it is basically the driving force is a factor that we can control or observe, right? But dependent variable is dependent on the input. So exam score is dependent on how you study, so how many hours you study. So exam score becomes your dependent variable in this case. So this is what is independent and dependent variable in linear regression model. This regression model is great for its predictive abilities because we're able to predict the future outcomes using the past data as our input. So we know that this has been the value of a stock market. For example, Apple stock has been like this in the past. So using that data, it is able to predict the future outcomes, and this is used in finance industry, healthcare and marketing as well. This is one of the most easy to understand model, and it is very simple and interpretable. It's easy to understand, interpret, making it the starting point for learning the machine learning algorithms, and we'll be looking at others, but those are a little bit more complex when compared to this. This is also the basis for other algorithms, be it logistic regression model or neural networks. They are all built on the concepts of this linear regression model. It provides analysis, or also called insight, between relationship between variables. Sometimes in machine learning we involve multiple parameters. For example, it can be temperature, speed and so many other factors when it comes to vehicles, right? So for that, how each independent variables are affecting or influencing one another, which is causing noise, that means that's not the correct one, or that does not have that much of a weightage in this regression model or equation, right? So that could be just introducing some amount of noise to your data, that means giving you absurd results, or then you have to see which parameter is causing that, and you have to reduce that or remove from the equation, which creates noise in the data. Let's look at the best fit line in a linear regression model. So what is this best fit line? It's a straight line that accurately represents the relationship between the independent variable and the dependent variable, which is your input and the output. It is linear, and also the difference between the actual data points and the predictive values of the model. So there should be minimum differences between the actual, what actually we get, from what is predicted. The deviation or the outlier should be very minimum. Outliers means those do not anywhere match the actual is never matching or close to the predicted ones, so that should be very minimum. So let's understand the goal of the best fit line. The goal of this best fit line should be to find that straight line which has minimum error or the difference between the observed and predicted values. This line will help us predict the dependent variables for new unseen data. That means we train the AI using something which is called training data set. You give all the examples and show AI that this is the data, and then you do not do the testing with the same set of data. You use a different data set which is called testing data set. So there are two things, training data set and the testing data set, which are the new data which is unseen by the AI. So even when a new data set is given for testing, we have to see that the line is straightened out. That means not much of a deviation. So let's take the example of this equation, y is equal to mx plus b or mx plus c, whatever we call it, as the equation of line, right? So x be the independent variable and value of y is dependent on the value of x, and hence it is called dependent variable. So when we understand this concept, we are able to analyze the equation and the things. So here b or c, whatever you call it, is a constant value. That's also adding on to the equation, but it's mostly x value. As it changes, y also changes. So that's how a independent variable value changes, and the dependent value is also dependent on the independent variable. Minimizing the errors, the least square method is used for this, that is yi minus yi dash. So what exactly does this mean? Find the best line, that is best fit line, using least square method. And what this says is that find the difference between the observed value and the predicted value. Yi is the observed one and yi dash is the predicted value. So when you find the difference of the observed versus predicted and find the square of it, it is called sum of squared errors. So that should be kept as minimum as possible. That's the objective. Keep the value as small as possible. So let's look at some of the limitations of linear regression model. It assumes linearity. That means if there is a relationship, right, y is equal to mx plus b. So if x changes, y also changes, and that's a linear relationship. But if in your equation or your particular scenario the relationship is non-linear, then this model is not going to work for you, and this is not the right model for going about. And sensitivity to outcomes. Outliers can significantly affect the model. So if your outliers is too much and is showing you're not able to achieve the best fit line, then also this model is not for you. There are two types of linear regression model. One is called the simple linear regression model, where the equation is y dash is equal to theta 0 plus theta 1 of x, or you can say y equals mx plus c, the same equation. Similar to that is the simple linear regression. But you have a second type which is called multiple linear regression, that is y dash is equal to theta g plus theta 1 of x1 plus theta 2 of x2 plus so on till theta n of xn. So what this comes to say is there are multiple independent variables, not just one. So that's the approach in the multiple linear regression model. So let's look into this more in the next session. Thank you. And before I conclude, a quick reminder, I have a nature playlist, nature related and nature mystical, and these two playlists are amazing. And also, if you are someone who likes inspiring stories of startup companies, I have a separate playlist where I've mentioned all of Google, Amazon, and Apple, all these companies' amazing journeys. So please do take a look. Thank you.